Дмитрий Арсеньевич, добрый день.
Меня слышно, слышно. Видно? Нормально?
Вас прекрасно видно.
Ага, замечательно. Приветствую. Ага.
Все, хорошо.
Мгм. Я проверяю, как будет все работать. О, видно мою презентацию?
Да, прекрасно видно.
Мгм. Хорошо. Мгм. Я параллельно на другом компьютере запустил трансляцию в YouTube. Если что, можно будет видеть вопросы.
Отлично.
Оперативно. Ага. Хотя времени у нас немного будет. Ну, что поделаешь. Да, Алексей? 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 Привет. Ну, все, я вроде в Zoom, трансляция в YouTube тоже идет, так что, в общем, вот готовимся. Ну, трансляция идет, но идет подготовка, имеется в виду, что меня уже там видно. Меня там уже видно. Там Алексей Маслаков. Алексей, вы меня слышите?
Да, я вас прекрасно слышу.
Вопрос такой. Мне потом после презентации пленарной надо сразу на секцию переключаться. Там как-то написано, что за 15 минут до начала секции надо включаться. Как это сделать? Я же буду в этой комнате.
Вам никуда не надо выключаться, оставайтесь здесь.
Но мой доклад на второй секции, на втором канале.
Так, секундочку, дайте мне посмотреть программу. Вам нужно после пленарного доклада за 15 минут до начала секции просто выйти из этой комнаты и войти в комнату номер 2.
Войти туда. Ага, и меня пустят, да? Просто там перерыва нет, как я понимаю.
К сожалению, да, но надеюсь, что мы закончим пораньше.
Ага, и тогда переключить. Ну все, выйти из этого и войти в тот. Я понял, да. Все, спасибо.
Dear participants, we will start in 3 minutes.
Дим, так у тебя комната 1 написано.
Алексей Валерьевич, там немножко поменялось. Будет вести Марина Карулина секцию, а во второй комнате он будет делать доклад за своего соавтора.
Кто будет делать доклад?
Дмитрий Арсеньевич.
У меня Павел не может сделать доклад технически, поэтому мне придется делать.
Понятно. Вот об этом. Так а ты видео... там будет Маринка. Понятно. Все, я понял, о чем. То есть у тебя двойная будет нагрузка.
Ну, как двойная? Просто, да, то, что в один день, ну, да.
Да. У тебя на разных секциях доклады еще. Так, Адим, ты начинаешь или Диана будет?
Меня, наверное, представить, и я начну.
А Диана потом будет?
Я
Диана потом, да.
Вас, объявлю, что сначала вы, потом Диана, через минуту буквально.
Очень постараюсь, да, так сказать, тут ужаться, естественно. Вот, и чтобы ей осталось время показать.
Dear participants, you are welcome to the 4th day of POAC conference held in Moscow. Today we have the 5th keynote lecture from Dr. Dmitry Anishenko. We have some schedule changing since Diana Kidji was presenting her keynote speech without the presentation. He will start just after the Dmitry's talk, and we will enjoy the slides which were expected to see yesterday. So we will split our keynote lecture into 2 parts. First of all, I'd like to invite Dmitry Anishenko to present his lecture, Priority Offshore Projects of Gazprom PJSC and Ice-Related Scientific Problems. Dmitry Anishenko, please, you are welcome to share your screen and start your presentation.
Just a moment. I do this. Okay. Can you see my presentation?
Yes, go ahead.
Okay, fine. Thank you. Good afternoon, dear colleagues. Thank you very much to the local committee for inviting me to give a plenary lecture. I am working for VNIGAS, which is a scientific branch of Gazprom. It's a rather big institution. We have more than 2,000 people on board. All problems connected with gas finding and exploration is included into the area of interest. There is a specific center responsible for offshore oil and gas development for Gazprom, of course, from the scientific and engineering point of view. And I am glad to present some scope of tasks in which we were involved. And mainly, I put your attention on some quite interesting scientific problems, some of which have been solved and some of which are under consideration till now. So the short description of the contents, several words about Gazprom, but I will omit them due to time restrictions. I will show main Gazprom's current offshore projects, and then put your attention on some scientific ice-related problems and several words in conclusion. I omit this about Gazprom. You can find comprehensive information on the website of the Gazprom shown here. Then directly to main Gazprom's fields in which we have now our main attention. The main areas are the Sea of Okhotsk over here to the far east located, then the Barents Sea, where well-known Stockmanovskoye field is located, then the Kara Sea nearest. We have here two huge gas deposits, Leningradskoye and Rusanovskoye, but the question about their development is only under consideration now. And in the Gulf of Ob, which is the bay of the Kara Sea, Gazprom has a number of licenses for offshore fields, Kamennomyskaya Sea, North Kamennomyskaya, and some others. And these two fields are under designing right now, and within several years, a stationary platform should appear in the Ob Bay. Evidently, ice loads and iceberg threats are the governing environmental risk for offshore structures, and not only for offshore structures, but also for performing marine operations that needed to be met within the development projects. I mean, ice loads and iceberg threat. Seismic risk, which is main risk for Sakhalin, is beyond the scope of my task. And later on, I will return to these fields. Two words about Russian policies for shelf. Only state-owned companies right now have rights to conduct work on the Arctic shelf. Gazprom, mainly for gas responsible, and Rosneft, mainly dealing with oil, and all their subsidiaries. So you may frequently meet the title Gazprom Neft, which is responsible for Приразломное in particular. Another large company, Lukoil, is a private company. It successfully implements several projects in the Caspian Sea and in the Baltic Sea, also under ice conditions, but these areas do not belong to the continental shelf, so Lukoil has rights to deal with them. Several words about actual platform which are in exploration right now. In the Baltic Sea, jacket type Kravtsovskaya oil platform, responsible is a Lukoil company. Then well-known Приразломное platform in the Pechora Sea. And again, in the Pechora Sea, which Pechora Sea is the south east part of the Barents Sea. Well-known Lukoil's oil terminal Varandey, which is under exploration quite long period. Then about Приразломное, I would like to show your attention to the rubble piles near one and another part of the hull of the platform. We will return to this problem. I mean, the formation of rubble piles later on. Then we go to Sakhalin shelf. 5 platforms are now in exploration. Molek-Pak caisson type gravity-based platform, Lunskaya platform gravity base, having 4-column type. You can see in the photo the stage of the construction Lunskaya A platform and another similar to it, Peltuna-Stokskaya B platform. They are performed from concrete and again are gravity-based structures. On the photo left, you can see the process of installation of top structures over previously installed support structure for Lunskaya, and in nice condition you can see this platform. Note please the ice jam between the legs of the platform. This should be taken into account when calculating ice loads, definitely. Another platform, Orlan platform, which is installed in Sakhalin shelf in 2005, but before that it was a mobile drilling platform. It was constructed in 1984 and has been in exploration on the Beaufort Sea shelf. And the last one, the newly one platform, Berkut platform, again of the similar structure, and it is shown how it goes to the place of installation, being afloat. Then we go to the Gulf of Ob to show the rather newly installed oil terminal with the name the Arctic Gate. It's operated by Gazprom Neft. The terminal is unmanned and it is working during several last years. And here we can see how the process of oil offloading is performed in OP Bay from this terminal. Please note the rubble pile around the terminal power. So this could be some specific topic for designing platform for Kamenamyskaya Sea in the OP Bay. Now we go again to Sakhalin shelf. In order I could show some results of recently performed research work performed by NIGAS. There is a lot of different license blocks on Sakhalin. Now in the focus for Gazprom is the so-called Sakhalin 3 project or block Kirinsky. At the moment, Kirinskaya field is under exploration, and it's interesting for that this is the only field on the Russian continental shelf where the resources are extracted by purely subsea production facilities. So only subsea facilities, manifolds, templates, and pipelines, and no fixed, no floating platforms. And similar approach will be realizing in development of the nearest Kirinskaya South field. Note that here we have harsh climate system. Ice cover is present for about 7 months per year. Of course, we have no ice loads. Water depth is 100 meters and more, but the ice cover is essential obstacle for various marine operations, including necessary subsea well inspections and repairs. So the importance of correct determination of ice regime characteristics is very important. And during 15-20 years, for these 6 years, a big research problem was performed at the request of Gazprom, where a large volume of field studies of natural conditions was performed, including 2 expeditions with icebreaker. Yesterday, the leader of these winter expeditions, Dr. Sergei Pisarev, gave his very interesting presentation on some specific ice features on the Sakhalin shelf performed. Then mathematical computational modeling has been performed, and using reanalysis data, we will calculate for the 30-year period and using high-quality hydrodynamical models for atmosphere, for ocean, and for waves, and for ice cover. The program are shown here. A lot of data for metocean elements have been calculated. And finally, rather strong probabilistic modeling has been performed to calculate the operational and extreme characteristic of metocean elements. So I would like to pay your attention that the data for 30 years has been obtained for the whole the Sea of Okhotsk. Some pictures here show you the dynamics here, velocity, surface currents for October of this year. Time step is 1 hour. On the right, rather interesting picture where we determine the events of compression in ice in violet color. This is shown, time step 6 hours. And it's interesting to note that in principle, these events are coming in more or less repeatedly sequence. due to tides, but sometimes there are another situations. Definitely, sometimes we have situations with very strong compression in ice in this area. On the right, you can see pictures responsible for showing concentrations of ice for severe winter 2001 and for extremely warm winter 2015. Time step is 12 hours. Can you hear me? I found some.
Yes, you were muted for approximately 20 seconds.
20 seconds. Okay, I will repeat. So for this work, complete fields of ice cover parameters are calculated for the whole Sea of Okhotsk for 30 years period with space resolution 3 kilometer and time step 1 hour. So a huge amount of information concerning relating to ice conditions. The main problem was well-known program Sea Ice, and I think that you know that a lot of ice parameters are included, and among them are ice concentrations, thickness of level ice, thickness of deformed ice, effective thickness of ice that is averaged over the calculation cell over the area occupied by ice, average draft of hummocks, ridge kills, velocity of ice drifts, velocity of deformation, and some others. And we performed monthly tables of joint occurrence of various variables, which are very helpful for planning marine operations. I have no time to show some detailed information, but you understand that, for instance, this picture 29, this is the percentage of time within the second decade of April when the thickness of ice is within this interval 70 to 95 centimeters. And we have a lot of such tables for all relevant ice parameters. Then, besides operational characteristics, which are important for marine operations, all extreme characteristics of ice related to a prescribed return period has been calculated for several points of interest on the eastern shelf of Sakhalin. Some examples are given here. For instance, in April, the expected extreme effective ice thickness can be about 4 meters with a return period 1 time per 100 years. And we introduce associated values. Some methods were proposed. Associated values for concentration of ice is not very high, 0.4, and in March we have 3 meters ice thickness, lesser, but with associated concentrations 0.9. So these months definitely are the main when possibly we will design offshore structures, whether stationary, whether floating. Then we are going to the Ob Bay in order to show some interesting situations which began take place last years. So the field Kamenomysskaya Sea is under designing and under construction right now. The platform is under construction. it will be caisson type platform, but with piles due to not very big water level here. Here we can see general view of ice level and some specific features like cracks. Here the local view of crack, the width is about 2-3 meters, and on the cosmic pictures we can see the huge cracks going from one side from the bay to another. This gives some ideas about possibility of winter motions of ice cover. It's interesting to note that in 2016, the terminal mentioned above was put into exploration right here. The future location of platform will be here, and definitely due to rather intensive shipping near this terminal, now we have the situation when the ice cover of the north part of the Ob Bay, that before was like one unit, rather strong, now it is cut along it with the traces of icebreakers and tankers, and definitely it is not so strong, and there is reason to believe that the ice regime could have changed significantly. And some evidences for this. It's some funny pictures that sometimes we can obtain information not from specific engineering surveys, but through some very brave people. In 2070, one guy had a very extreme car ride in the Arctic. You see in red its path over Tazovsky Peninsula, Gdan, Yamal, and across the Taz Bay and across the Ob Bay. So this last part is very interesting for us. And through the photos presented by this brave guy, we can see that he and his friends, they have met a number of cracks near exactly the Cape Kamennomysky, where the platform will be located, and some specific ice features, etc., etc. Then it's a usual cosmic photo before the terminal began to work, rather strong cover, and now you can see the picture after the terminal began in exploration. In white we can see clearly the channels broken by icebreakers, and in black we can see large cracks resulting from the global deformation of ice cover. And in this picture we can see the very characteristic view that the whole ice cover, if shifted along the Ob Bay direction, we have very characteristic zigzag cracks. That means that we have the global deformation of ice cover, and definitely this global deformation can give additional specific scenarios for winter ice loading on the future platform located somewhere there. So this is quite interesting, changing in ice regime within several years. And finally, I would like to say about well-known Stockman project. We know that the project was suspended in 2011, but at that time the technical solution adopted for the project was a disconnectable, ice-resistant floating production unit of ship shape with disconnectable internal turret mooring system. This means that in case of iceberg threat, this special buoy should be detached from the hull of the platform, and then the FPU can go away and avoid the possible impact of the iceberg. This solution was checked previously in Newfoundland Bank for two projects performed on the Terra Nova and White Rose. But it's important to note that in the case of Stockman field, the size and mass of this turret and this buoy could be very high, extremely high as compared to other situations. So some additional technical risks, of course, are present using such type of technical solution. So at the moment, the idea is to find another technical solution. At the picture, we can the location of the Stockman field, and here within distance about 150 kilometers, we have so-called Goose Bank with water depths about 60-70 meters. And the idea is possible idea to locate here stationary platform, and this could diminish a number of risks connected with the use of floating platforms in the central part of the Barents Sea. Some information is useful for us and give some support for such an idea. At the picture, we can see the current scheme at this location. We can see that all currents are directed not from the north part where icebergs can occur, but against there. So maybe it is possible to avoid the main danger for the platform, namely iceberg danger. We have performed some analysis. We found the location of one probability occurrence of icebergs in the Barents Sea. We can see that the possible point at the Goose Bank is in good conditions with respect to this line. Again, more detailed current situation is favored for us. However, we should take into account that in 2003, the expedition of Arctic and Antarctic Institution found a lot of icebergs almost directly at the Stockman site, and this group of iceberg was going through southeast to northwest in such direction, and so it's very important to estimate the real iceberg risks for Stockman. Unfortunately, my time is going very fast. Anyway, I should add that there is some information about frequency of iceberg occurrence. This possible new site is in favorite positions with respect to this data. Some restricted simulations performed, for instance, by RE specialists show that again this new position could be rather suitable for platform location. And now the idea is to repeat for the Barents Sea the whole project performed for Sakhalin Shelf, about which I have said before, to obtain for a period of from 40 to 50 years the whole information about all metocean parameters, and then use this environmental data for modeling iceberg drift. Again, we need to elaborate, of course, some iceberg drift model based on the best current practices. And then we plan to perform a massive Monte Carlo simulation, and the result of which will include all calculation cells reached by the model iceberg during drift. And then analyzing by statistical methods this information, we could be substantiate the possibility of more or less safe location of future platform in the Stockman Sea. And finally, during 3 minutes, I hope I would like to show that some lesson learned from the study of iceberg impact processes. It's important to check the energy balance during impact. I mean that the iceberg thread is consisted from two parts. First, the probability of iceberg occurrence near the structure, and then the loads which iceberg can give to the structure during its physical impact. And this analysis directly relates to the discrete element method models, which very frequently used in the studies of ice cover loading on offshore structures and ships. So very brief.
No sound.
Is it okay with my sound?
It's okay now.
Okay, thank you. So some schematic picture. Let us imagine a vertical structure with vertical hull. It's a plan view. This cone is chosen for simplicity because it's quite easy to analyze, to perform a parameter analysis depending on the eccentricity of location of this asperity and the angle of asperity. And the main question is, are details of contact force value, direction, and point of application important for the modeling? We understand that during the contact, we should establish contact force, give a set point of application, and give the direction of this force. Frequently, in DEM models, such an equation is used where the contact force is proportional to the overlapped area or overlapped volume within the contact. We perform some calculations, and we have found some rather strange thing. Here we can see a sequence of iceberg approaching to the structure, right angle between blue and red color, began contact, then some indentation, and then indentation and reflection, and then iceberg is going away with some additional rotation. here we can see quite a good contact force diagram, but the analysis of energy balance shows us that we have loss of kinetic energy. So the difference between initial kinetic energy and the final kinetic energy due to rotation is not zero, so something goes wrong. It was found that the main reason is that this equation is wrong, that it's not correct to take contact force proportional to the area of volume overlapped of these two contacted bodies. The correct form is in such a form where we have the length of chord multiplied by the height of the contact, and then some coefficient of proportionality. And here, in such a situation, K has a very clear physical sense. This is the local strength of icebergs on compression. For instance, it was taken as 2 MPa for calculation. And finally, to show all is okay with energy, the contact force is approximately the same, but with some modification, of course. So the main conclusion here is that if we not check the energy balance during the impact between two bodies, we can obtain some error in energy balance. It's difficult to say whether it's very important or no when we use million of interconnections bodies like ice flows or no, but I suppose that anyway one should perform this balance energy checking for two interconnecting bodies within each other, and only then to perform a huge calculations with thousands and thousands elements. So I come to my conclusion. So we can see that a lot of problems till unresolved exist in Gazprom projects connected with offshore platforms. So I'm sure that there is no end to ice studies. So I am sure that there is no end to POAC conferences. So thank you very much to all participating in the conference, and looking forward to participate in next one and etc. All the best. Thank you very much.
Thank you very much for your keynote lecture. We have 1 minute for one short question. So if someone from the audience wants to ask something from the speaker, please, you are welcome. Alexei, maybe you want to ask something, since we don't have questions on YouTube chat so far.
Yeah. So do you have some sort of classifications of iceberg shapes, which could be important for collisions?
No, we did not perform such an investigation. Definitely this is important, and now we are trying to collect some set of possible icebergs and give some probability distributions of different shapes and their dimensions, etc., to use in the future Monte Carlo simulation.
Because I mean shape of local features. Important.
Okay, I see. It was in restricted model calculation shows that the that the problem is larger. I mean, with energy error when the impact is strong. That is when the angle of iceberg asperity is large.
Mm-hmm. Yeah, and maybe one more question. So we were working on icebergs near Spitsbergen in last September. So, and ice was quite warm. And we discovered that strength properties are quite different from winter time. So then,
Yeah.
so
Yeah,
I think the temperature is quite important for the forces.
Yeah, it's a good comment, and definitely this parameter should be included in the iceberg modeling. And if we will be able to produce iceberg drift model including these effects, this will be very good. Thank you for this comment.
Thank you very much for the presentation. And since we have tight schedule of our plenary session, we would like to gratitude Dr. Dmitry Onищенко and switch to the next speaker. Diana Kidji will give us some presentations. Since yesterday we had some technical problems. So Diana, please, you are welcome to share your screen and start your presentation.
Good afternoon to everybody once again. And thank you for this possibility to show my presentation. And now, can you see my presentation?
Yes, you may start.
Okay, thank you very much. So to continue yesterday's speaking, I'd like to show you some slides, very short, very quick, to illustrate things which I was speaking. So here you can find some our devices like radar in the left part, the console for ice console for the radar in the right part, and here you can see how we can look the satellite pictures, ice satellite pictures. The main instrument for us to find our global directions. Here you can find also the electronic chart display information system and the GPS GLONASS receiver with which we make our navigation. And so to continue speaking about the ice, as I said yesterday, the main ice chart characteristics which we should take in mind while navigating are thickness, concentration, compacting, and hammocking. So here on this picture you can see, for example, the part of Ob Bay. This is February of last year. Here you can see the first year ice flows with hummocks, quite serious flow, and such flow can cause difficulties not for us, for the icebreaker, not only for us, but especially for the gas carrier. So two types of icebreaker assistance: leading and towing. This is how it is. And to speak about navigating in fast ice and in drifting ice, it's a very important theme for us. I want to show you some pictures. Here on this picture you can see a drifting ice with an ice channel, which is quite good, but on the next picture you can see very clear how it is when the ice is drifting. So distance between icebreaker Vaigach and between our icebreaker 50 Let Pobeda is not very big, it's just 1 mile. It's a usual distance between ships in a convoy. And you can see very clear that ice channel has a drift, part of an ice channel has a drift. So after this, I can tell you that there was not only drifting, but even compacting of an ice. And we have stopped in this flow and we were waiting for about 3 hours when we could start to move again. Well, speaking about navigating in Ob Bay, I'd like to show you some pictures of an ice in the Oak Bay. The main problem there, it's parts of the fast ice after it has been opened in about beginning of April, and such flows of the fast ice are usually very hammocked, and it is a real problem for us to proceed through such flows, because we are considered by our draft, and we can proceed only through the deep water route. So we cannot go near such flows, but we should go through them. And it takes quite a long time for us to make a nice channel to proceed. Here you can see how it's in real time. And speaking about sea channel, the Oak Bay, yesterday I told about wind roses. You can find directions of the wind in February and in March of 2019, based on observations from board 50 лет Победы. And you can see that wind more than 10 meters is quite often for this area. And here you can see that the wind of southwest direction is quite often as well. But here you can see a picture with the most unpreferable directions of the wind for us. And here you can see that the red triangle from both sides of the channel is quite big. So really we have not so much window of wind direction when we can proceed very safely through the channel. Here on this slide, you can find calculations of the drift of a vessel, depending on the speed of the vessel itself and the speed of an ice drifting. Here in this line, you can find speed of a vessel, and here you can find speed of an ice. So you can see that with a small speed of a vessel, drifting becomes quite strong, and that means when proceeding the channel, we should have speed not less than some parameters, depending on the weather conditions. And this could be a real problem, because if we stopped in the channel, we begin to drift to a boundaries of a channel quite quick. So this detail should be in mind as well before entering the channel, because this is quite difficult for us to make round in a channel. And usually if we cannot proceed through the channel from some point, we should to go back by stern, because it is impossible for gas carrier to make a circulation in boundaries of the channel. And here you can see a picture of proceeding in a convoy, including distance between ships and including distance of drifting. And Captain Lobosov, captain of the icebreaker 50 лет Победы, and Captain Skrabin, master of icebreaker Vaigach, has made some calculations based on this picture. Here you can find them. This is dependence of drifting of a vessel under icebreaker assistance in a convoy, independent of speed of an ice, and independent of the speed of a convoy, and independence of distance between vessels. So here you can find that we cannot make our distance of course, we cannot make our distance too close, because in case of sudden stopping, it may cause to damage to vessels. It may cause to collision. But also, we cannot make this distance too big, because the gas carrier would proceed with a very small speed. And because it increased a risk to go out of boundaries of the channel also. Here you can find these tables of calculations. And as a resume about navigating in the Oak Bay, about navigating through the sea channel, I can say that, of course, icebreaker assistance to the gas carriers should be provided only in individual order. If ice conditions are even medium, and of course, if ice conditions are very hard, of course, it is possible only by leading because of our dimensions, and based on my experience and experience of my colleagues, we decided that usual optimal conditions of proceeding in a convoy are distance about 12-13 cables, but it could be increased to 15 cables in easy conditions. And speed also not more than 12-13 knots because of risk of low depths, because of risk to go out of boundaries, but also not less than 7-8 knots. As I said yesterday, it's recommended to proceed near the opposite boundary of an ice drifting. It's not recommended to enter the channel if drifting is more than 7 degrees. And of course, about small cargo vessels, it is more preferable to escort them by towing, because impossibility to make fast a tow line inside the channel, and because lack of time to break the ice near the board of the vessel in case of its jamming. This is how it looks. A small cargo vessel, a small tanker on a stern, has stopped in an brush ice, and we were trying to break the ice near the board of this vessel, but finally we had to tow it through the channel. And this is a picture from our winter passage to the east in February. It takes us 8 days to proceed to the Bering Strait, and 12 days to come back with a gas carrier. And also the most difficult ice conditions were in the East Siberian Sea and in the Chukchi Sea, with a medium, 1 year, but medium ice with hummocks of about 3 points and with compression of 3 points. But we are sure that we can proceed in winter time, maybe in January and in the early February, and to proceed in May because of ice conditions. And we're sure that with building the leader, we can reach an economical effective speed of convoy during such transit passage, even in the winter time. So we hope that the building of a leader would make more preferable the Northern Sea route by foreign ship owners and for new Arctic projects. And as I said yesterday, the one more problem of navigating in ice is problem of communication between the vessel and the icebreaker. It is problem of lack of experience of crew members of cargo vessels, and probably it is necessary to extend the ice navigation courses in training centers, devoting more time to the interaction of the vessel's crew with icebreaker. And we find that it is very good practice to have on board of a vessel so-called ice advisor. This is an officer with good ice navigating experience who can be on a bridge as a chief officer of navigational watch to give advices and to navigate with an icebreaker. And so I think that is all that I wanted to show you in my presentation. And thank you for your attention. Thanks to the organizers for invitation and for the possibility to show you these slides today. And if you have some more questions, I'm very glad and ready to answer you. Thank you very much.
Thank you, Diana, for your impressive slides, impressive presentations. I think we have several minutes for questions. Maybe someone would like to ask them. As far as I see, we don't have questions from YouTube chat. Maybe someone.
I have a short question.
Yes, please.
Diana, do you expect any problems in case of collision of icebreaker with thick ice or with Tamuha?
Well, you know, we're trying to go away from very thick ice and from parts of icebergs and from Stamuchas. And yes, I think very hard ice, especially if had been attacked with a very big speed of a vessel, more than 12 knots, can cause damage to the vessel and can cause damage to an icebreaker. And so one of the tasks of the navigator, of the chief officer of navigational watch on an icebreaker, is to go away from such parts of an ice.
Mm-hmm. Thank you.
Thank you. Another question from the chat. So what was the largest ice thickness you ever overcome?
Well, you know, the largest was more than 1.5 meters on board 50 Let Pobedy. But, you know, for us, more problem give, not the thickness of the ice is more problem for us, but it's hammocking and compression. Even the ice less than 1 meter, but with big hammocks, with big point of hammocks, and especially with compression, can cause very big problems for us, much more than just proceeding through the good 1.5 meter ice.
Okay, thank you for your answer. I think we have some minutes just to finish our plenary keynote talks. Thank you, Diana, very much for your talk.
Thank you very much, Alexei.
We now are switching to the session number 24, and I will forward my duties to the Marina Karulina. Thank you. Marina, you are welcome to prepare to the session.
Yes. Here no in our room our presenters. Oh, okay. One is here. And
Marina, we have a video from first presenters from James. He is not here, but he sent the video.
Oh, okay. Only video. And how long is this video?
15 minutes.
15 minutes, because we cannot ask the questions to video. Yes. Okay, and one more presenter should be in our session. Oh, I see. Yuri Gudoshnikov. Hi.
Николай Кубышкин.
Я. Здрасте, Коля. Я не разглядела, потому что у меня очень мелко было. Я смотрю, а написано Юрий Гудошников.
Это с его компьютера мы выходим, у нас общий доклад.
Все, я поняла, да, я видела соавторов, да. Okay, we have all presenters and one video. First presenter sent video. Let's start, I think. Hello to everyone who joined our meeting. Welcome to the session number 24, named Ice Management. And I'm a convener of this session instead of Dmitry Onyshenko. So we have 3 presentations in our session. And first one will be video. Some words about me. I'm Marina Karulina. I work at the Krylov State Research Center and in the navigation training complex for ship navigation. So let's start with first presentation video. Please, technical assistance, I think will start with this video. Okay. There is no sound. The first presentation is deployment of an enhanced ice profiling sonar, IPS, in seasonally ice-covered coastal waters of the Nonansuavik region of Labrador, Canada.
Okay, please tell me if will we hear sound now.
Yes, now we hear. Please press. Oh, no, it's too low. We cannot hear.
You don't hear, James?
We don't hear. It's too poor sound, too poor voice.
Okay, I'll try to improve it.
Too weak.
One moment.
Okay.
Field projects was on the east coast of Canada in the Nunavut region of Labrador,
Okay.
and I deployed an enhanced ice profiling sonar. So I was going to talk to you a little bit about that today. So some of you might already know about the ASL ice profiler already, but I'll start with a quick introduction to the instrument. This study made use of a prototype IPS5 with a logarithmic detector. So one of the things we wanted to look at was to get a better idea of whether or not the log IPS could bring various target types out of saturation. So we'll look at that a little bit. Both the traditional linear IPS5 and the log IPS have the ability to record up to 5 targets, but we wanted to confirm how the new log IPS performed with respect to handling multiple targets. So we have some new results to look at there. We also looked at backscatter amplitude as it related to different target types. And we'll also take a look at a few acoustic profiles as well. All right. ASL's ice profiling sonar is a single frequency sonar device that sits on the ocean floor or in a top line mooring configuration, like you see in the diagram to the left. It's used to measure ice draft, and it was first developed at the Institute of Ocean Sciences in Canada. Following that, further research was done by ASL to develop and commercialize the product. The first commercial use of the ice profiler was in 1996 out of Russia off Sakhalin Island. Following that, additional work was done to develop the IPS-5. The IPS-5 was introduced in 2008. It had a faster sample rate, was able to record multiple targets per ping. It had an increased number of phases, more memory, and the ability to do wave measurements as well. Since then, more research and development has been done to develop the log IPS, and I'll talk to you a little bit more about that. ASL's log IPS is a further development of the IPS-5 ice profiler. It has a logarithmic detector with 85 decibels of instantaneous dynamic range. The goal of this, developing this log detector, is to record weak targets as well as strong targets out of saturation. So we wanted to have enough range that weak targets didn't fall below the noise floor and strong targets didn't get clipped. So development of the log IPS started in 2013. We initially started looking at data that had been recorded by the traditional IPS-5 and simulated what it would look like on the log IPS. In 2014, we did some testing in local waters around Vancouver Island in British Columbia. And then in 2015, 2016, we had it out in the Arctic for its first ice measurements in the Beaufort Sea. During that test, we detected some issues with the electronics, and we identified some areas of improvement there, made some adjustments and put it back out in 2017, 2018 for another overwinter and full year deployment in the Beaufort Sea again. Following that, we were able just before COVID hit in 2020 to get the log IPS out for some new measurements in Eastern Canada off the coast of Labrador. And so that's the study that we'll be focusing this presentation on. In February 2020, ASL collaborated with the Nunatsiavut First Nation government in Labrador to study the ice in the coastal waters about 40 kilometers east of the town of Nain. Traditional hunting and fishing activities are undertaken in this region, but the changing climate has provided a greater urgency to understand the ice conditions in this area and to manage the risks that are associated with it. In the bottom right, near the top of the image, it's possible to see an area of open water surrounded by ice. This type of feature is known locally as a rattle, and it remains ice-free throughout the year. This rattle was located about halfway between the town of Nain and where we placed the mooring. In other parts of the world, I think these features are also known as La Niña. So a secondary objective of this study was to understand how these rattles affect the ice and the biology in the waters around them. Because it was February and everything was frozen, getting out to the site was a bit of an adventure for me. We loaded up all the gear onto a few sleds and towed it out by Skidoo to the deployment location. I think it was around minus 45 or something like that day, and one of the coldest days of the year, but it was the only time we could get out there without a bunch of fog and winds blowing over a gale. So yeah, it's cold, but the best opportunity we had to get out there. Once we got out onto the site, we cut a hole in the ice and assembled the mooring and deployed through the ice. The mooring was deployed in about 100 meters of water in an area where we expected to see a pretty dynamic ice regime, especially through the spring and summer as things melted up. So this slide shows that we had quite a bit of variability in what passed over top of the mooring. In one day, over about a 16-hour period in May, we had open water at the beginning of the day with waves and turned into calm water later in the day. And then following that, in the afternoon and evening, we had ice keels moving into the water about depth of about 8 meters. At other times, not shown here, we saw keels up to about 13 meters in depth. So this gave us a really interesting environment to further test the capabilities of the log yips. So here we have a histogram of the acoustic backscatter for 2 different time periods. At the time of writing, the data has not been fully analyzed, but as a way of looking at target type, we broke the deployment into 2 parts: winter, shown in red, and the full deployment, shown in blue. The full deployment being from February to November 2020. In both cases, the number of observations tends to 0 as acoustic backscatter approaches the limit of the A to D, around 65,000 counts. The red curve, we know that is dominated mainly by ice and has a single peak, while the blue plot shows ice as well as open water. And we can see that in both cases, the ice and open water are out of saturation. Interesting also to note is the open water period seems to have 2 peaks. And we don't fully understand why yet. We suspect that it might have something to do with the sea state at the time. This histogram is from our 2017-2018 deployment in the Beaufort Sea. We've had a little more time to go through this data in more detail and identify the different target types. While we do see some overlap in backscatter signal from different target types, this allows us to start assigning odds to what we are seeing. Below 40,000 counts is likely to be deformed ice. The probability of level ice and deformed ice is similar above 45,000 counts and drops off with increasing backscatter. And then as you increase above 50,000 counts, the probability of open water increases. Okay, so this slide shows the capability of the ice profiler to record up to 5 targets. We've broken down the number of times the IPS recorded 1, 2, 3, 4, or 5 targets over the last 3 trial deployments. The first plot, which is shown in blue, is recorded by the linear IPS5, which has been included here for comparison. The obvious thing that we notice is the lower number of single targets and large number of incidents where 5 targets were recorded during the 2014-2015 study. We were unsure at the time if this was going to be consistent with log IPS measurements, but we have since determined through subsequent deployments shown in the green and the purple plots that the issue was related to a bug in the electronics of the log IPS. That has since been corrected, and you can see that in the 2017 deployment and the 2020 deployment, we were able to determine that the target detection algorithm behaves similarly in the log IPS as it does to the linear IPS. Okay, so in this slide, I just wanted to show some possible characterizations of ice features shown in these acoustic backscatter echograms. In panel 1, in the top left, it shows a 2-layer system with level ice and what may be frazzle ice, where indicated there with the arrow. Met data from Maine at the time showed temperatures around 0 degrees Celsius and winds 8 meters per second easterly, which does not favor the formation of frazzle, but conditions east of Maine in the offshore, where it might have been colder and had additional heat loss driven by the wind, it's possible that the formation of frazzle may have occurred there. So in the second panel, on the top right corner, this shows a period of deformed ice coverage with approximately 4-meter ice keels. It also shows periods of low backscatter, unconsolidated ice, and sections of higher backscatter ice. And then finally, in the third panel, we see level multi-layer system with lower amplitudes than the first panel, probably due to the ice type. Also, the larger dynamic range appears to allow the IPS to peer into the ice a short distance. To summarize, this deployment in Maine allowed us to test the log IPS in a new ice regime. Due to COVID-19, recovery of the data was delayed and processing has not been complete yet, but we are working on that. And at the same time, we have another year of data collection underway in the same location. What we did learn from this is that, yes, the log IPS was able to bring the air-water interface out of saturation, that the target detection algorithm behaves similarly to the traditional IPS, that there's a possible relationship between target type and amplitude, and that there appears to be an ability to see multi-layering and variations in backscatter strength through the ice. Thanks everybody for your time and for listening to this presentation. If you have any questions or comments, feel free to reach out to me at my email address that's on the screen there, or I think there's also an opportunity to post comments below this video during the conference. Thanks again.
Thanks the presenters and the organizing committee for possibility to see this presentation. Maybe someone has any comments. I don't see any comments on YouTube channel, but maybe someone of our auditorium has. No, unfortunately, we cannot ask question directly to others, but we can use email given in the presentation. And I have one comment, because our section is ice management. And one of the components of ice management system is monitoring of current ice conditions, forecast of them, and providing the navigators with actual information about on ice conditions, on the current ice conditions. So we need various devices to for measurement current conditions, for measurement ice thickness. It's interesting how we can use the presented device for these purposes. It's my opinion. And now it's time to continue. And second presentation is on a question of the regulatory framework development for providing transport and offloading operations in the fast ice in the Russian Arctic. Nikolai Kubyshkin will present this work. Please, Nikolai.
Запустить презентацию это.
Share. You should share вот.
Зеленая клавиша демонстрация экрана. У вас есть?
Внизу, вот если вы курсор вниз проведете.
Зеленая демонстрация.
Share screen, зеленая, там написано.
А уже сама презентация, там уже где-то у вас на экране есть. Вот такой подход. Или кто-то сейчас умнее подскажет, но, по-моему,
У вас на экране была запущена презентация?
У меня запущена, да.
И
да.
Тогда демонстрация экрана.
Нажал.
Сейчас тогда прилетит.
Share screen нажали?
Там надо выбрать потом презентацию, нажать совместное использование.
Да. Вот мы видим.
Отлично.
Development of regulatory framework for supporting transport and cargo operations on fast ice in the Russian Arctic. The practice of the use of coastal fast ice for the creation of transport infrastructure in Russia. Historic experience, organization of ice crossings of rivers and lakes by the ice cover. The most striking examples were the ice railway crossing over Lake Baikal in beginning of 20th century, and the Road of Life over the ice of Lake Ladoga in the Second World War. Yamal-fast ice operations, annual unloading of sea cargo vessels over the fast ice of the western coast of Yamal Peninsula, Kara Sea, Cape Karasavay, 19th years. Single cargo transportations with unloading our fast ice were implemented in USSR since 1960s in points of Novaya Zemlya, Franz Josef Land, Pechora Bay. Cargo operations were carried out in closed water areas that simplified the choice of safety mooring points for vessels and road laying over the ice cover. In 1976, the experimental voyage of motor ship Pavel Ponomarev was taken with the support of an icebreaker Lenin. The cargo was unloaded on the fast ice and transported on shore by the ice roads in the area of Cape Karasavy. Successful experience had initiated the mass vessel transportation of the cargo to the western coast of Yamal Peninsula in winter-spring period with unloading over fast ice. On this map are demonstrated sites of the cargo unloading operations in 21st century in the Russian Arctic. The most activities in open Yenisei region of Kara Sea. Since 2013-15, the unloading of vessels through fast ice is carried out at from 3 to 7 sites in the Russian Arctic per ice season. Estimation of carrying capacity of an ice sheet is a key question of all kinds of ice engineering operations on the ice cover of natural water bodies. Generally, carrying capacity of ice sheet is a function of ice thickness and expressed by Gould's formula, where carrying capacity of ice depends from ice thickness. In Russian ice engineering practice, different modifications of this formula are used, based as solution of task of elastic response of ice to applied load as empirical data. Some of these see below. Pещанский formula for calculation of carrying capacity of ice, we need to know ice thickness and some mechanical properties of ice. Another simple empirical formula for fresh and saline ice from Kazansky and Schudman. We need to know only ice thickness, ice salinity, temperature of air temperature, and conditions of loading on ice. When we work on sea ice cover, we need to take into account ice and specific ice and hydrological conditions for ice roads constructions on fast ice. First, structure and morphology of ice cover. Second, hydrological conditions, and fleet activity, effect on ice from icebreakers and vessels. Some of listed factors are similar to conditions of road building over the ice cover of mainland water bodies, rivers and lakes, but many of them are specific only to the areas with the seawater and require special measures for safety support. On this slide are shown some examples of fast ice operations. The northern part of Oak Bay, Karasavy Cape, Cape Kamenny, Oak Bay, Franz Josef Land. The Russian guidelines and instructions for road laying, preparation of cargo sites, and another in the infrastructure objects over ice, cover of water bodies. The most known are the guidelines for organization of ice crossing on ice roads. GOST, VSN, ODN, GOST 2020, VSN reprint of 2000, ODN, the oldest guideline of this. The guidelines for hydraulic engineering construction using ice and building material and ice cover at base. RD 1989, SNIP 1987. These are not quite modern guidelines. For unloading of vessels via first ice, we have two documents from Soviet period. RD 1990. The document summarizes the long-term USSR experience in unloading vessel through fast ice, examines the full range of issues: organizational, ice engineering, navigation, and hydrographic, hydrometeorological support, transport cargo, as well as labor and environmental protection. It should be noted that this document is outdated in terms of planning, organization, and operation management. Recommendations for carrying out cargo operations in the fast ice in the Arctic, 1986. These recommendations similar to RD. The Roshydromet has new safety regulations for observations and operations in the Roshydromet network, 2017. Chapter of the regulations by unloading of vessels via fast ice contains all necessary instructions for implementation of preparation, cargo, and transport activities at vessels unloading via fast ice, but only for single vessel. This document also considers specifics of execution of works in Antarctica. In 2020, the Arctic and Antarctic Research Institute published a meteorological manual on special hydrometeorological support for unloading vessels through the fast ice. The manual addresses hydrometeorological issues, ice engineering aspects on the fast ice infrastructure arrangement, coordinated actions of the operator of hydrometeorological support with the fleet and coastal mechanizations, labor protection for the personnel working on ice. The manual builds upon the long-term experience of working on the fast ice during Soviet time, described in the old recommendations, and RD summarizes the others findings on fast ice operations in 21st century at the sites of Arctic coast of Russia, the western coast of the Yamal Peninsula, Ob Bay, Yenisei, the Novosibirsky Islands, Franz Joseph Land, and another. This manual can be used in the development of a new guidance document or a set of rules for the arrangement of ice roads and sites for various purposes on fast ice. A special guide needed by organizations and specialists involved in the developing the Arctic coast. Thank you for attention.
Thank you, Nikolai, for very interesting presentation. And now I don't see any questions on YouTube channel. Maybe they will appear in short time, but okay. I have a question. Have you analyzed any international documents regarding the offloading, onloading and offloading operations on fast ice? Are there such documents, and maybe how useful they are for practice in Russian Arctic?
We know some documents on ice roads in Canada, but I don't know any documents for unloading ships on the fast ice.
Okay. Thank you. And there are no any other questions? And thank you once again. And now we continue with the last presentation. Last presentation is Russian experience of cargo and passenger transportation on ice off-road. And Sergei Pisarev will give presentation. Okay. Please. Please share your screen.
Yeah. Because
Okay,
it's
okay.
something with my particular internet in just in this moment. Previously very good, but now not. Okay, it's Admiral effect, you know.
Yes, okay. It was the same with my internet just before the session.
Yeah, it's, can you see this beautiful title or not? Can you see something?
No.
No, sorry. So let's.
Okay.
Okay. So okay. I also can see. Okay, let's try. Let's imagine that we have the possibility to investigate ice in the same manner like in previous presentation. So it was classic. In previous presentation, we see the classic approach when we need to transport something through the fast ice, some reload, some ship, and it's a huge and serious operation. But let's imagine that we have some construction in water that's seasonally covered by ice, firstly, and then such ice can deform in any moment, and it's a different type or thickness of ice, but nevertheless, we would like to transport something, not only people, but something more serious, some luggage, something like this. And the goal of my, let's say, presentation, it's just to collect information, what we have in Russia at the moment to do such things, just transport through the ice off-road. Do we have any things? And now my computer, again, don't like to change my beautiful picture. It looks like very slowly internet. So let's wait a little bit. So everybody see only title, nothing else, right? Okay. Plans for construction and maintenance of various marine infrastructure, drilling, shipping terminals, and that's all, in the sea covered with seasonal ice required the solution, among other tasks, of the issue of the cargo and passenger transportation from coastal bases to these facilities. Very often we use helicopter to do this, but it's a helicopter, as we know, very highly dependent on weather condition, and not so big, big cargo we can transport regularly. Of course, we have huge helicopter to transport huge cargo, but it's exceptionally expensive. And in many situations, transportation by icebreakers or vessels with high ice class is difficult if your construction on a depth less than 20 meters. And of course, in Russia exists a huge experience just to construct something through the frozen rivers, lake, and this process well studied, comparing with other countries. And one beautiful example we see in previous presentation. But nevertheless, if we need to transport something without possibility to investigate this particular stable ice, do we have any devices to do this? And let's start with some devices that I not plan to describe. For example, simple skidoo, and you know the skidoo very easy if you met some crack. Skidoo come through. It's me many years ago in Central Arctic. My skidoo, I cannot find this snow-covered cracks or even little leads. And bulldozer, it's also near North Pole. Bulldozer, people also not check the ice, and bulldozer goes through the ice, and now he just balanced here, and later they go down. And we even not look on such beautiful devices like this tricol, but nevertheless, it's like car, so it's not so interesting for this particular presentation. Let's look what we have to transport something like 3,000 kilo or more and more. And we have excellent example like hovercrafts. And we will look on a so-called Arctica hovercrafts. I especially not translate like Arctic in English because original name in Russia, Arctica. And why this particular hovercrafts we look? Because I like these hovercrafts, and look like the best machine for task that I described previously. And it's a robust design. They produced in Omsk. Robust design. They have some framework of this hovercraft constructed by titanium and aluminium, and we know some difficulties to maneuver with hovercrafts. It is difficult so that you cannot quickly stop, and when you turn left or right, you need big distance to do this. So you practically cannot rotate on a place. But this particular model have good titanium brake pads, so they more or less have sharp rotation in any direction. And such devices have two engines, and if one engine broken, exists practice that other engine it's enough to move nevertheless. The material of the fence of this particular hovercraft, it's synthetic with rubber, and it's some special model, so they just hard enough to go through the not only through the snow, but through the even little ridges also. And such model unsinkable with 200%, so it's practically impossible that they go down. And such devices meets the requirements of the river register of Russian Federation. And I know exactly that such hovercraft many years used in several places in Russia. So exists good experience to work, and for example, they work on some near Khabarovsk. They work as a bus, as a ferry through the Amur in any ice condition. They just transport people from one beach to another. So it's exists experience to do this, and just it's not Russian experience, but I very like to demonstrate this. maybe you know, it was interesting experiment when Norwegian hovercraft, but hovercraft itself was constructed in Swedish and used many years by Swedish army. Then some private people buy this hovercraft, and then Polarstern transport this hovercraft here near the North Pole, and then was 2 people only have drift from August 2014 to August 2015, and it's good experience how it's possible to use hovercraft when you move from the unpredictable drifting ice, not fast ice, not serious investigation of ice, but just you would like to use these devices and you need this. And of course, people who drift during 1 year demonstrate us, I will say shortly, that practically such hovercraft, when he stayed long on one place, they frozen to the ice. It's very difficult to start after 2 weeks of the not movement. The hovercraft of such size cannot cross the ridges more than, I don't know, 0.7 meters, not more. And even such 0.7, it's very big for such hovercraft. So exists some difficulties to use hovercraft. And in Russia, we have, by the way, several same type of hovercrafts that also used practically in some river, not for investigation. It's like a river bus in winter ice-covered period. It's they have different name like Hevus or Mars, but construction principle is the same. But what the Arctica have some advantage, wheel advantage. So such devices have special wheel like in an airplane with hydraulic aircraft type landing gear. And look, this is Arctica hovercraft just in normal situation, but then they start to use this wheel and became bigger. And on a short period, when it's necessary to cross some angle on ice, on a land, something more than 20 degrees, you can use this wheel and slowly move through the sun up or down. So it's very effective things as addition to the normal hovercraft possibilities. And then practically the biggest hovercraft that now you can buy and use, and people from Omsk already constructed previously, it's hovercraft that transported only 5,000 kilo of cargo, or something like 15 people inside when they used as a bus. But exists some plan or fantasy, who knows, we'll see. But exists some construction, but not product, but constructions, some calculation and so on, some huge hovercraft with lifting capacity 60,000 kilo, and also planned, but without technical documents. This have technical documents, but nobody, let's say, have order. Nobody would like to buy this up to now, or pay for this. But this even bigger hovercraft that have lifting capacity 150,000 kilo. And exists some other also like fantasy or maybe like near future, who know, there exists some additional devices for such hovercraft. It's roller track powers. They just used, as constructors say, just planning to use to crush a bush on a land or ridges on the ice. We'll see, because there are no practical construction. It's difficult to say how realistic this devices is. The same like these two. But what is realistic and have huge practice, it's hovercraft that can transport it 5,000 kilo on a distance more than 1,000 kilometers. And price of this hovercraft, if we calculate the transportation on 1 kilo on 1 kilometers, it's more than 10 times cheaper than helicopter. And of course, they're not so weather dependent as helicopter, and safety enough. And if you have not planned to stay in one places, but you plan to move from one land places to some your facilities near the shore and back, so it's look like that such devices have to work properly. But of course, limitation only 5,000 kilo. And pilot to work with helicopter much more complicated. You need some place for landing. You need qualified pilot and so on. Hovercraft, it's not so difficult, and normal driver can start to drive hovercraft after several exercises. So it's not the same problem like helicopter pilot. Another thing that we have here in Russia, it's aerobots. They differ from the hovercraft, that there are no air to the bottom. It's the same engine, and they just go through the water or ice and so on, just have a friction. It's simple boat. And again, the biggest what we have now, and we can buy, and some factory produce such so-called Phantom. It's cabin capacity 14 people, or a lifting capacity of 2.5 tons, not more. And exists another modification of this Phantom. They have lifting capacity 3,000 kilo, but, and this is like cargo. You see this deck, you can put some luggage here. But what's this problem when we look on ice? That it's inflatable body of this particular aerobots. And to use on the ice, there are no such experience. And with my point of view, such boats, it's dangerous. Having inflatable body, just go through the Zastruk, ridges and so on. So there are many dangerous for inflatable body things on ice. And then a look on these interesting devices. Car with low pressure tires named Yemelia, and there are no experience to use this car for the transportation, for regular transport, more or less regular transportation. It's let's say more car for the adventures now. And very beautiful guys who construct this car, they real adventure, and they have about 10 years of expedition on the Arctic tundra and on the fast ice of the Russian Arctic seas. And in 2009, they carried out hike of drifting ice from the Arctic coast of Russia and reached the North Pole. I just was here when they finished their trip, and of course it was a very, very difficult trip, despite the fact that all this team very strong, because they very high-level alpinist previously. Now he not so young, not decide not go to the mountain, but start to construct such machine. But nevertheless, it's interesting devices because they just cross drifting ice, drifting Arctic ice from Arctic coast of Russia to the North Pole. And in 2011, they have even more interesting hikes through the drifting ice from the Arctic coast of Russia to Canada. And they use such devices, but what we see, that the speed, it's not so big, something like 45 kilometers per hour. Such devices can float but speed on water only 3 kilometers per hour, and engine also not so, let's say, energetic. And what is interesting for my let's say investigation, that they can transport only 2.5 thousand kilo. So not again, not so many for many purposes. But nevertheless, it's machines that really work and really have experience. And look, despite the good characteristic of such machine, they also have a lot of problem when you go through the ice. You know, you can cruise, but nevertheless, you cannot like flight like hovercraft through the leads or cracks. So you all time have thinking what you do, looking forward, and determine the best way. So it's not direct way. And some other picture, and such car not damaged, they just again return and continue to trip. It just trip to the North Pole. And this also look special devices. This person look what the ice condition where the ridges exist, because of course, despite that huge clearance, such car cannot go through the ridge more than 0.6 meters, not more, even less, 0.5. So it's you have to find your own way. And the same car people use in Antarctica. Look, they use another type of wheel due to some reason, because in Antarctica they expected more hot ice, so they decided to use another wheel. But generally, it's the same system with track and some additional transportation and living box here. So such devices have practical example, and it's interesting, but not used for normal people transportation before, but maybe in future. And last example, it's very interesting trip of Russian military motorists on a heavy tracked ambiguous tractors through the ice on the Laptev Sea. They start in Tixi.
Sergey, 2 minutes.
Sorry, I need finish. So they start in Tixi, and look, they cross Laptev Sea and then go back. And please look, it's this machine with 2-link tractor, with they can transport 33,000 kilo, and this is biggest, is record now. And only we have to say that on a way from Tixi to Novosibirsk Island and back, they practically use fast ice. It's not drifting ice at all. But of course, it's another 10 such devices can transport 10,000 kilo at all, and can have this like crane. And another device also 10,000 kilo, and this is some special block container in secondly. And of course, such devices not go through the ice, even in such crash, step by step, all these devices was on the ice again, and it's possible to repair engine even in dark night. So it's interesting experience, but again, it's up to now it's still too sporty, too many adventures. So to say that this is possible to use as regular transportation for some reason, it's not moment yet. So what's the result? That we have huge experience, but we need additional choice and investigation of such construction if we would like to have something that can transport people or some luggage more than 10,000 kilo from shore to some not so far facilities that stay within the drifting ice. Thank you for your attention.
Thank you, Sergey, for very interesting presentation. And we have still no questions on YouTube, but we have some delay between translations on Zoom and in YouTube. So I would like to ask you about one interesting factor. Have you considered possibility to use some vessels, vehicles, or boats to transport goods in Ob Bay? Regarding Ob Bay, what do you think? What is your experience?
Let's say, I'm personally not transport nothing up to now in the Ob River Bay. It's firstly. Then I think that, of course, in ice condition, as I know in such region, it's hovercraft will be best with all difficulties that anyway exist. So, but hovercraft, with my point of view, is the biggest perspective, and particular such hovercraft with this wheel, because using this wheel you can more options to cross ridges, and of course hovercraft not go through the ice, not so heavy, so it's more safety, and price is big, of course, but not so big like helicopter. So, but of course, I think it very depends what particular region. If there are a lot of ridges here, so it's impossible to organize such transportation, because no devices among that we see, these 4 types of devices, they cannot cross real ridges. So, and if a lot of ridges, they only will stop. So it's impossible. But in some region, of course, on the fast ice, of course, it's possible. If ridges are organized here, we can choose another way, something like this. So it's dynamic work. I think it exists some perspective. Yeah, it's necessary additional investigation together with, for example, this military institute. I communicate with this guy. They're very enthusiastic to go in new trip with any purposes. So they good mechanics. They ready to change something. They understand what industry maybe need.
Thank you. Thank you, Sergey, and for the presentation. And now we have about 15 minutes before the closing ceremony section, and we can discuss our item. And if here is Nikolai Kubyshkin. Are you here still, Nikolai? Can you see?
Слышу вас.
Oh, okay, that's good. I'm sorry for the non-answering the question, because it was delay between YouTube translation and our room translation in Zoom. There was one question from Anna Barker. He asks, do the guidelines now need to take into account impacts of climate change for operations? Do you understand? No?
Understand?
What is your opinion? Should we take into account impacts of climate change for operations?
Climate change, yes, climate change is influence of the operations because ice thickness depends of frosts, temperature of air. But in last years, when we must say about warming, we have not any difficulties with fast ice operations. We have some change in terms of beginning of these operations and finishing operations, but ice thickness allows drive onto ice and unloading cargoes on ice surface. And I don't think that in future, in the next years, we finished these operations because climate was will warmer. Я извиняюсь за не очень хорошее качество английского. Вот, ну, по-русски я добавлю, поскольку аудитория у нас, я как смотрю, больше на русском языке. Вот. Да, несмотря на заявляемое и наблюдаемое потепление климата, климатические изменения, потепление климата, мы не испытываем сейчас трудностей с разгрузками на лед. Более того, по количеству районов, где мы выгружается в российской Арктике ежегодно, вот, количество таких мест растет. И объемы перевозок, объемы грузовых операций сейчас ничуть не меньше, чем, вот, допустим, в 70-х годах прошлого века, когда считалось, что 70-е годы называют кратковременным периодом похолодания. Вот, тем не менее, в качестве примера можно привести грузовую операцию в северной части Обской губы, в районе Салмановского месторождения, когда с февраля по май было разгружено более 70 тысяч грузов на припай. Так что мы не ожидаем изменения и прекращения таких операций в связи с изменением климата.
Thank you, Nikolai. I try to translate your answer. Nikolai opinion is as follows. There is no need now to take into account impact of climate change for operations. Now there are no problems with onloading, offloading operations on fast ice still. Yes, it's correct. Is it correct? Okay. Thank you. And we have now 10 minutes. I will take the opportunity to give some words about my occupation in the field of ice management. If I can share screen, I would like to okay. I cannot share the screen because Sergey is sharing screen. Please leave this mode. Please unshare. Because our section is do you see my slide?
Yeah, we see your slide.
Okay. I would like to shortly to present our simulation, our training center for navigation simulation. Diana Kidji, if you listened to her, said on the plenary session yesterday and today that the training on navigational simulation is useful thing for the navigator and ice experts. And as I know, she used our simulator in the Krylov Center, and our center consists of 6 navigation bridges shown here, and as well as separate oil overlight management station and separate crane operation control station. And using all navigation bridges and special station, we can train, we can practice interaction between various objects. We can use all these navigation bridges at the same time, simultaneously. And one of the purposes of using this simulation center, this training simulator, is to practice in ice management operations. And this is pictures of our training center, of 2 bridges of our training center, and here are pictures which were obtained from the center, from the bridges. And here are some pictures showing how we managed ice before in front of приразломная platform in Barents Sea, when we tried to make broken ice instead of level solid level ice in order to minimize ice loads and to minimize forming of rubble piles before the platforms. Various ice management schemes, operations were proposed, and we practiced this scheme maneuvers on the our training center. This is short information about our work in the field of ice management issues. And thank you. I don't see any questions on the I stop share. I don't see other questions on our chat and on the YouTube channel. So I think we can close our session. Thank you very much for your interesting presentations. And in 3 minutes, the closing ceremony will start. So we have 3 minutes to have coffee break or tea break. Thank you.
Thank you.
What recording?
Сказали, что запись остановили. Скажите, вас капитаны слушают на тренинге? Вот вы их тренируете, а, по-моему, каждый капитан избирает свой собственный путь, как он разрушает льды. Вот он говорит, я капитан, и вот я сам знаю.
Нет, на самом деле не мы их тренируем. Как мы их можем тренировать, сидя за столом и рассказывая, куда им идти?
Да.
Вы совершенно правильно сказали.
Sorry for the interruption. We will have a closing ceremony in this room in 3 minutes. So
okay.
Finish your discussion.
Next time.
Thank you.
Yeah, thank you. Yeah.
У нас специальные инструкторы, короче.
Yeah, and we will have in this room. So it means that we have to stop our discussion and wait, close the ceremony. Okay.
Dear colleagues, good afternoon. We are about to start our closing ceremony. We will start in several minutes.
Alexei, the order session is still ongoing, so it's up to you to decide whether you want to wait for orders or...
Of course, sure. We will be waiting for them. Dear participants, the closing ceremony of POAC will start in several minutes. We are waiting for the finish of the last presentation in room number 2.
Good day or good night, colleagues.
Do we have somebody from region with night? We have, I think, Ivana is here. Walter Spring here. So Ivana will run the meeting, as I understand. Alex, oh.
Okay, let's start. And I would start and shortly from the according to our decision in the schedule of the closing ceremony. We start the closing ceremony now, and it's my pleasure to give a floor for the greetings to the head of the organizing committee, Dean of the Faculty of Geography, Professor Sergei Dobrolyubov.
Thank you, Sergei. Dear participants, dear colleagues, the POAC conference is about to finish. I believe that despite the online format, you had a great pleasure watching the presentations, keynote lectures, and sharing your experience with your colleagues for these 4 days. We did our best to provide you with well-organized conference program and created favorable environment for active interaction between participants during the sessions. The presentations were smoothly broadcasted and were available for a broad range of researchers and experts from all over the world. We are proud to be a host of such prestigious event in Russia for these days, and are grateful for the choice of Moscow State University as the venue for the conference. For us, this is an indicator of our high level and international recognition of Russian geography, geotechnics, engineering, as well as focusing of our scientific community on the development of world science, strengthening international cooperation and mutual understanding. We regret that you were unable to come to Moscow for participation in the conference in person, but welcome you to visit our city and our university in the future. Thank you for making your contribution to POAC conference this year, and good luck with your future investigations. Now I would like to give a word to Alexey Maslakov. He will provide you with some statistics and interesting information about the conference. Alexey, please.
Thank you. Dear participants, I'm also glad that everything was fine. I was happy to provide smooth sessions and a nice program with so many presentations. Let me give some interesting numbers for about this conference. So totally we had 149 registered users at POAC website. Not all of them were the speakers. So we had almost 100 of speakers who were presenting their presentation in 25 sessions for the last 4 days. We have a broad geography of participants covering 15 countries from all over the world. We also had 5 invited talks. One of them actually was split into 2 small talks yesterday and today in the morning. I hope you all enjoyed listening them. Here you can find some statistics on participation of participants from different countries. You can see the geography of the conference. Of course, the majority are from Russians, but also Canadian, Norway and Finland people also participated in a significant number in this conference. We received 107 abstracts and 92 full papers, which will be soon published. And I'm glad to announce that almost all of them are ready for uploading to the POAC website, and they will be published there within 1 or 2 weeks. I also calculated the longest and the shortest title of the presentation. That's quite interesting information, I think. The longest title is 22 words. You see it on the slide. The shortest presentation title has only 4 words. This is just strength on bonded ice. Such a quite interesting variety of the lengths of the presentations. So let me give a floor to Professor Sergei Dobrolюбов to announce the Best Student Paper Award.
Thank you, Alexei. And I am pleased to announce the winner of the Best Student Paper Award. In this year, this prestigious award is granted to Tim Hammer from Delft University of Technology for his paper, 2D test setup for scaled real-time hybrid tests of dynamic ice structure interaction. Congratulations to Tim. Along with the award certificate, the grant a cash prize of $1,000 US. The award is sponsored by the official sponsors of our conference. We are grateful to them for their support. And now I would like to give a word to POAC Secretary, Mrs. Ivana Kubat, for announcing the POAC Founders Lifetime Achievement Award. Please.
Good morning, afternoon, or evening to everyone. This year, the POAC Founders Lifetime Achievement Award is being presented to Dr. Walter Spring. Dr. Walter Spring has had a long, distinguished career that many of us know. His remarkable achievements over the past 40 years have been cornerstones for many of the advances in Arctic offshore engineering. While working on his graduate studies in physical oceanography, Walt joined Mobile R&D in 1975 and started his long career in the oil and gas industry. He soon after became attracted to the emerging activities in the Arctic. He carried out and directed several pioneering projects dealing with issues such as measuring ice pressures, computer modeling of ice islands, ice forecasting, iceberg detection, and construction of platforms in ice environments. Back then, those issues were big unknowns. Walt was at the leading edge of establishing the knowledge base that made Arctic offshore development possible. At Mobile, Walt was responsible for numerous major Arctic projects over the Grand Banks, Alaska, the Barents Sea, and the Caspian Sea. In 2000, Walt moved to Exxon Upstream R&D, where he stayed until 2006. Over there, his work was central to major Arctic developments. His contributions dealt with ice forecasting, alert systems, establishing environmental criteria for the design of offshore structures, and ice basin test programs for icebreaker and lifeboats. The projects covered most Arctic regions, including Sakhalin, the Caspian Sea, and Alaska. Following his long career at Exxon, Walt headed his own consulting company, Bear Ice Technology, from 2006 to 2016. Over there, he provided consulting to major oil and gas companies and continued his involvement in many high-profile Arctic projects. So throughout his busy and remarkable career, Walt was always a fervent supporter of POAC. He started with attending the first POAC conference in 1977 and has attended most of the following conferences until 2015. He was instrumental in attracting a strong representation from the oil and gas industry, which made POAC a primary forum for Arctic engineering. Walt was always active in chairing the direction of POAC through participating in the International Committee and organizing special sessions of significant topics. He also developed concepts for POAC awards, such as Founders Lifetime Achievement Award and Best Student Paper Awards. So in recognition of Dr. Waldspring's towering achievements and contributions to POAC, it is my pleasure to present him with the POAC Founders Lifetime Achievement Award. Congratulations, Walt, and thank you very much for all your contributions.
Thank you. Thank you, Ivana. I'd like to thank POAC General Secretary Ivana Kubat, the POAC International Committee, and the organizers of the 2021 POAC for awarding the Founders Lifetime Achievement Award to me. I'm honored to receive this award and join the previous recipients that have made POAC the premier Arctic conference in the world. Since attending my first POAC in 1977, I have flagged this conference as one in which the offshore oil and gas industry could present the results of its research for exploration and development projects. While economic and environmental issues have caused many Western projects to be deferred, I see this conference as a place to review technical issues so that when future projects are initiated, they can be based on a solid technological foundation. I wish future POAC conferences success and hope that climate change effects upon engineering solutions will be addressed within future sessions. Again, I'd like to thank Ivana and all those involved in the award presentation for this award. Thank you.
Thank you, Dr. Walter Spring. And now we have to move forward. And I'm glad to invite Professor Erkan Oturkus for his presentation of POAC 2023 venue. Please, Professor, you may start sharing your screen and show your presentation.
Thank you very much, Alexei. So let me just share my screen. Okay, I hope you can see it. Can you see my screen, Alexei? Okay, yes. Great. Okay, so it's a pleasure for me to basically introduce you the next POAC conference, which will be held in Glasgow. So I'm sure that basically many of you know where Glasgow is, but just to highlight its location, basically we are at the north side of United Kingdom, and we are located basically in Scotland. So the conference will be chaired by myself and also Professor Soren Ehlers from Technical University of Hamburg, and Professor Serdar Terkuş will be the conference secretary. So as University of Strathclyde in Glasgow, so it will be an honor for us basically to organize the next POAC conference. So for those of you who are not familiar with our university, we are one of the leading engineering universities in the UK. And also for this particular conference, basically, specifically the Department of Naval Architecture, Ocean and Marine Engineering basically will be in charge of the organization process. So as you may know, this department is one of the leading departments in the world, basically focusing on naval architecture, ocean and marine engineering research, and also education. So in terms of conference topics, basically we will have similar topics which were covered in the previous conferences. And in terms of city itself, Glasgow, so I'm really happy to mention that Glasgow is one of the leading touristic destinations in the world. And although it's a very historical city, it's very green and so on, there are many places to see. Actually, maybe the best thing about Glasgow is people. So it was elected as, or it was voted as the friendly city in the world. So I'm hoping that once you come to Glasgow, you will have the opportunity to see the friendliest part of Glasgow people. So in terms of conference venue, basically the conference will take place at our Technology and Innovation Center. And this particular building is part of our university, and it is located at the city center. So it's very easy to access to our conference venue. And also having the conference place at the city center, it's also easy to go to some other places. So in terms of dates, basically, we are planning to have the conference sometime in June, but this will be basically finally verified. So these are the two potential dates that we are currently considering, but basically we will inform you once we decide about the final dates. So this particular building is a pretty new building, and it was opened in 2015 by Queen. It is not just for conferences. Basically, it is also a place for research and innovation. So in terms of transportation, so we are hoping that in 2 years' time everything will be in an okay condition so that people can travel safely. So there are two different airports that you can actually use to reach our destination. One of them is Glasgow Airport. It is very well connected, but also you can travel to Edinburgh as well, and Edinburgh is just less than an hour distance from Glasgow. And for those of you who will need UK visa to enter United Kingdom, so we'll be really happy to provide you the invitation letter so that you can apply for the UK visa. How about weather? So basically, Glasgow weather is very much different than many other places for the summertime. So I believe, it has its weather is somewhat better with respect to many other places as well, because it is not very hot during the summer. So we are expecting that the average temperature is about 17 degrees Celsius. But also, I also recommend you to bring an umbrella as well, because in Glasgow, it can always rain anytime. So in terms of accommodation, basically, since Glasgow is a touristic destination, we have many places to stay. And since the conference will be located at the city center, again, there are many options. So as you can see here, this is the city center of Glasgow, and you can see the thick building where the conference will take place. And there are, as you can see, there are many hotels around this area that you can actually choose to accommodate. Okay, so I have actually a very short video before I conclude. So I'm hoping that it is going to play. So just a second. Okay, let's see. Okay. Okay, so just go back to my slides. So my final slide is basically, we will have the honor and pleasure to welcome you, and also, of course, welcome POAC 2023 to Glasgow, Scotland, and we are looking forward to seeing you soon in Glasgow. Thank you very much. Just
thank you, Erkan, for the presentation.
Just a second, let me stop sharing my screen. If I can find, yeah, right there. Okay.
Thank you for the presentation of venue of POAC 2023. It seems to me that Glasgow is a very lovely place, so it should be very nice to be there. So we will move to our final stage of the closing ceremony. And I would like to give a floor to POAC Secretary, Miss Ivana Kubat, for her talk.
So again, thank you. Thank you very much. I think it is fair to conclude that the conference was a great success. The week went by very quickly. We've heard many interesting presentations, and thanks to the YouTube recordings, we could attend concurrent sessions and will be able to view the presentations for a few more days. So on behalf of the International Committee, I would like to thank Professor Dobrol-Lyubov for hosting and chairing the very first fully digital POAC conference. And I would like to present him with the POAC virtual plaque.
Thank you.
I would also like to thank to the local organizing committee, particularly Dr. Alexei Maslakov and Dr. Sergei Khalov, for who worked very hard to make this event successful. We all know this that it has taken numerous sleepless nights, particularly during this week, to ensure a smooth conference. You, Alexei, Sergei, and your team did an amazing job. Next, I would like to say thank you to all the presenters who took time to write papers, prepare great presentations, and present them often very early or late during the day. And I cannot, of course, forget thanking to all reviewers of the papers, session conveners, my colleagues on the International Committee, and the members of the Best Student Paper Committee for reviewing all student papers and selecting the winning one. All papers, as Alexei mentioned, will be posted on the POAC general website in early days, soon after the conference. So finally, I would like to thank to all participants who attended the presentations and asked interesting questions. I will now conclude by inviting you all to POAC 23 in Glasgow. Thank you very much.
Thank you, Ivana. So the conference is finished. Congratulations. Thank you very much for participating in the conference, and goodbye.
Bye-bye.
Thank you very much for all attendances and for International Committee of POAC. Thank you.